All right, this is Harrison and Calbert, and we are giving our presentation on entity relation diagrams. Next slide. So first off, what is an entity relation diagram? According to SmartDraw, an entity relationship diagram shows the relationships of entity sets stored in a database. An entity in this context is an object, a component of data. An entity set is a collection of similar entities. These entities can have attributes that define its properties. ERDs are used in database design and show how information is passed and acted on within a database. Next. When designing an ERD, there are several shapes we use to design our system. Starting on the left column, we have a simple entity denoted with a rectangle that stores information. It's much like a struct that contains fields that hold information. Below the entity is a weak entity, denoted by a double outlined rectangle. Weak entities can't be defined with their attributes alone and require that they be linked to a different type of entity with a foreign key. Next, we have an action in the shape of a rhombus. An action relates two different entities. For example, an entity might create, contain, or modify another entity. Moving to the right column, we have attributes. Attributes are unique characteristics of an entity and are denoted by these ellipses. A simple attribute has a simple outline, but attributes can also have multiple values. These kinds of attributes have a double outline. And lastly, a derived attribute drawn with a dashed single outline is based on another attribute. Going off of one of SmartDraw's examples, a derived attribute could be an employee's monthly salary derived from their annual salary. Next slide. There are several different styles of connectors when designing ERDs, but we'll just focus on information engineering style for this presentation. Here we can see the many different types of relationships entities can have. There are a few important things to know that will sum up these type of connectors. A single perpendicular dash through one end of a connector says that the relationship is mandatory and that there must be at least one entity on that side of the connector for the design to work. If the end of the connector is forked, there can exist many of the same entity in the relationship. If the end of the connector has a circle, the entity's existence is optional and is not required for the design to work. We can see that these properties can be combined to make more specific relationships. By combining a dash and a circle, the relationship means 0 or 1. If we combine a fork and a circle, the relationship means 0 or more. By combining a fork and a dash, we get 1 or more. The only relationship that is unique is the double dash here, meaning one and only one relationship can exist. Next slide. Here's an example from SmartDraw of an ERD. This shows the database design of an internet sales model. We have company, items, shopping carts, orders, customers, and more. Starting from the company at the top right, we see that its name is a unique attribute. One company produces at least one item, and each item has a name and a price. From the item, one or more are contained in one shopping cart or one order, and one shopping cart creates exactly one order. We can also see that any number of customers can order one or more items. Customers have a name, address, and email attributes, and also initiate shipments that have credit cards. Next slide. Here's an example of a very simple design for our app. The main focus of our app is making journal entries, and perhaps users will want to own multiple journals that contain multiple entries. Entries have a unique date and time attribute. Multiple, or none at all, can be contained in one journal. Journals have a unique name attribute as well, and any amount of journals can be owned by one user. If users opt to have an online cloud account with our app, they can have a unique email attribute. Next.
Okay. My name is Calvert, and I'll be following with the presentation. And we're going to talk a little bit about the upsides of the ERD. Visual representation. Most crucial benefits of an ERD is that it offers a visual presentation of the layout. Having an effective design provides assistance to the database designers to determine the flow of the data and working of the complete system. Effective communication. The readers can easily understand the relationship between different fields. There are various symbols for representation, for representing different information, like relationships are represented by diamond shaped boxes, attributes by ovals, and entities are represented by rectangles. Easy to understand. Entity relationship diagrams can easily be created by expert designers. These are designed in a simple manner so that all individuals can understand it easily. High flexibility. This is yet another feature of ERD models. Though the complete database is linked to information in different tables, the readers can easily make out the relationship between various tables. There are several other mathematical formulae which can be used to determine the relationships. Now we're going to talk a bit about the downsides of the ERD. Limited constraints and specification. Because of how the ERDs are set up, it might be hard to include constraints and specifications in the graph. Loss of information and content. Some informations be lost or hidden in the ER model because they can be massive depending on the application. Because the ERD can be so expensive, it might be hard to show relationships and attributes. Limited relationship presentation. ERD model represents limited relationships as compared to another data model like relational model. No representation of data manipulation. It is difficult to show the data manipulation in an ERD model. Popular for high-level design. The ERD model is very popular for designing a high-level design. So it requires people that are experienced and know the full extent of the application. So we're gonna, now for the next slide, we're gonna talk about the recommendations of when you use the entity relationship diagram. So how we can see a diagram. While ER models are mostly developed for designing relationship database in terms of concept visualization, in terms of physical database design, there are still another situation when ER diagrams can help. Database design. Depending on the scale of change, it can be risky to alter a database structure directly in the DBMS. Database debugging. By visualizing database schema with an ERD, you have the full picture of the entire database schema. You can easily locate entities, view their attributes, and identify the relationships they have with others. In requirement gathering, determine the requirements of the information system by drawing conceptual ERD to the high-level business objects of the system. Such an initial model can be also evolved into a physical database model that aids the creation of a relation database and aids the creation of process maps and data flow for the models. Here is another slide for the references that we use to create this presentation. And this concludes our presentation, and thank you very much.